Hi, good morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. In last lecture we derived a theory for body which is inclinedly immersed, and we found that we derived the equation for total pressure and location for center of pressure. Now in today's lecture we are going to solve some example based on that theory, body immersed inclined in a liquid. So let's start with our first example, where first example is a rectangular plane surface 3 meter wide and 4 meter deep lies in a water such a way that its plane makes an angle 30 degree with the free surface of the water. Now determine total pressure force and position for center of pressure when upper edge is 2 meter below from the free surface. Now in this data, the shape of the body given to you is a rectangular surface. So here as you can see, this is your rectangular body. Width of this rectangle is 3 meter and depth of this rectangle is 4 meter. Okay. Now here is free surface of the liquid. The body is inclined at angle 30 degree from the free surface. So here you can see that this rectangular body is inclined from, this is your free surface of the liquid, and rectangular body is inclined at angle 30 degree. So that angle of inclination, this angle of inclination is 30 degree. Now as we know that B, that is 3 meter, and 4 that depth which is 4 meter. Now G, that is center of gravity, the distance of free surface, we are taking projection here, and the distance of free surface to center of gravity, that is h bar. So this distance is your h bar. The another point is P, and the distance from free surface to P, which is h star. So that distance is your h star. Here in this case you have to find out total pressure force and location of center of pressure. So the another thing in example given to you is that the upper edge is 2 meter below the free surface. As we know that this is upper edge of this rectangular. If we are find out this distance, then this is 2 meter. This distance given to you is 2 meter. So this upper edge is 2 meter below from the free surface. Okay. Now here we are indicating some points here, that this point is A, this point is B, this is C, and this is D. Now we are drawing a line passing from C, this line, okay, and this point is your point E. Clear? Now this angle is theta, 30 degree. So if we are finding out angle here, then this angle is also 30 degree, this angle is also 30 degree. Okay. Now the depth which is 2 meter below. So this depth is 2 meter. This distance is 2 meter. Clear? Now area of this rectangular plate, which is 3 into 4, that is 12 meter square. And if we have to find out h bar here, then as you can see from the diagram, you can write down h bar equals to AE plus, or you can say h bar equals to 2 times B into E. H bar equals to 2 times B into 2 plus BE, because this distance 2 plus BE, as we know that this distance is BE. So h bar equals to this plus this. So 2 plus BE, 2 plus BE. Now as we know that this angle is also a theta angle, theta is 30 degree. So if we have to find out BE and we apply the equation for sin theta, then here BE, sin theta equals to BE by BC, BE by BC. So here BE equals to BC sin theta, BC sin theta. Here we know the theta, that is 30 degree. So total h bar which is 3 meter. H bar equals to 2 plus 2 sin 30, that is 3 meter. h bar equals to 3 meter. Okay. Now again this is a diagram for your inclined immersed body. Now if we have to find out total pressure force, that is F, and equation for F is rho g A into h bar. In this case it is immersed in water, so rho is 1000. We know the area of the body, which is B into D, 3 into 4, that is area, that is 13, h bar, that is 3, and G 9.81. So your answer for total pressure force is 353.16 kilo Newton. Now another part, that is center of pressure, which is H star, and the equation to find out H star for inclined immersed body, that is Ig sin square theta upon AH bar plus H bar. Now we know the equation, all the values we know here, the all values, where Ig, that is 16, sin square theta, that is 0.25, divide by 12 into 3 plus 3, that is 3.11 meter. So here H star, the final answer for H star, so distance of center of pressure from free surface is 3.11 meter. Okay. Now our another example, where the data given to you is a circular plate 3 meter external diameter and 1.5 meter internal diameter is immersed in water with greatest and lowest depth below the free surface is 3.6 meter and 1.2 meter. Determine total pressure and position of center of pressure. Here in this data, first of all, circular plate is given of diameter 1.5 meter, 3 meter, and there is a hole, internal diameter, external diameter is 3 meter and internal diameter is 1.5 meter. So here this is your circular plate of diameter 3 meter. Now there is a internal diameter which is 1.5 meter. Now the distance from here, it is given to you that the greatest and lowest depth. If we are finding out this depth, then this is your lowest depth. Lowest depth from free surface is 1.2 meter. The greatest depth, if we are find out this, then this is your greatest depth from free surface, because the body is immersed inclined. So this is your lowest depth and this is your largest depth or greatest depth. So greatest depth from free surface is 3.6 meter. This is given to you. Now we have to find out total pressure and center of pressure. So here this is point G, center of gravity at center, and the distance from center of gravity is h bar. The another point is point P. Here point P is here, and the distance from free surface is h star, and the angle of inclination is theta. The angle where body inclined, that angle is theta. Okay. Now if you draw a line here, then this is your angle, theta angle, and this is your free surface of the liquid. If you draw the line from here, then this angle should also be a theta angle. Okay. So this is the diagram of your immersed body. Now we have to find out area. Then what is the equation for area? Area equals to pi by 4 capital D square minus small d square. So we know the value for capital D square, which is 3, and small d square, which is 1.5. So you get capital A equals to 5.3 meter square. Now Ig, that is pi by 64, capital D raised to 4 minus small d raised to 4. So your answer for Ig is 3.727 meter square. Now we can find out h bar. So here h bar is average of greatest and smallest depth. As we know that from G, the distance is your h bar. H bar is the average depth of lowest depth and highest depth. So you can find out h bar equals to 3.6 plus 1.2 divided by 2. So your h bar equals to 2.4 meter. Now here the theta is not given to you. Theta is not given to you. We have to find out the angle theta. What is the angle theta here? Then equation, if we apply equation for sin theta, then sin theta equals to 3.6 minus 1.2. Total depth is 3.6 minus 1.2. So this depth, so theta equals to 3.6 minus 1.2 divided by 3. Okay, this 3.6 minus 1.2 divided by 3. So sin theta here, value of sin theta is 0.8. Now equation to find out total pressure force is F equals to rho G H bar into A. Now rho, that is 1000, G 9.81 and capital A 5.3, H bar which is 2.4. So your final answer for F, that is 124.78 kilo Newton. Okay. Now secondly, we have to find out center of pressure, that is H star, and the equation for H star is Ig sin square theta upon AH bar plus H bar. So no, we have all these values. Ig, that is 3.727, sin square theta which is 0.8 into square 0.8 square divided by 5.3 into 2.4 plus 2.4. So your final answer for H star is 2.587 meter. This is distance of center of pressure from free surface of the body. Okay. Now our another example, here a rectangular plane surface 1.5 meter width and 3 meter long is immersed in water horizontally. Remember that we derived two theories, first for vertical member and second for inclined immersed member. Here a plate is given to you which is immersed horizontally. This is vertically, this is inclined, and if plate immersed like this, then this is your horizontally immersed body. Then you have to find out total pressure force on the plate. So this is your plate which is immersed horizontally. Now this is your free surface of the body. The distance of plate from free surface is 2 meter. So this distance is 2 meter here. Now this is your distance H bar. Here this is your distance H bar, distance of free surface to center of gravity. Again in this place, this is your center of gravity. So total force acting from point G here. Okay. So to find out total pressure force, first of all area for this plate is 1.5 into 3 which is 4.5 meter square. Now H, that is 2 meter. H is 2 meter. So total pressure force equals to rho G A into H bar. Now F equals to rho which is 1000, G 9.81, area which is 4.5 and H, that is 2. So total pressure force F equals to 88.29 kilo Newton. In this plate, this is placed horizontally. Okay. So done for the today. We completed our chapter which is total pressure and center of pressure today. Now in next lecture we will discuss another topic of this subject, fluid mechanics and hydraulics. Okay. Goodbye.